Jai Hind, my dear children. Today we are going to discuss about Kirchhoff's rules. Kirchhoff's rules was first formulated by the scientist Gustav Kirchhoff. Kirchhoff rules are used to calculate current through different circuit elements and their potential difference in a complex electrical circuit. This is a complex circuit. We can find out the current through the bulbs and the current through the resistance by using Kirchhoff's rule. Kirchhoff's rule consists of two rules. First one is junction rule or Kirchhoff's current rule, KCL or point rule. The second rule is Kirchhoff's voltage rule or KVL or loop rule or mesh rule. The junction rule is, in an electrical circuit, the algebraic sum of currents at any junction is 0, or the sum of currents entering the junction is equal to the sum of currents leaving the junction. See the given circuit. Here at the junction A, I1 and I2 are the currents entering, and at the same junction I3 and I4 are the two currents leaving the junction. Hence we can write I1 plus I2 is equal to I3 plus I4. The second rule is loop rule. In any closed loop of an electrical circuit, the sum of potential difference across different circuit elements is equal to 0. That is, the total potential difference in a closed circuit is equal to 0. See the given circuit. This is a complicated circuit. We can find out currents through each branch by using Kirchhoff's rule. Now we can study some sign conventions for applying loop rule. So loop rule is otherwise called mesh rule or Kirchhoff's voltage rule, KVL. Okay, so there are some sign convention for applying loop rule. So we consider a loop like this. So this is the loop under consideration. Here a single cell is here. Let the current is I1. Here at the point I1 splits to form I2 and I3, and here the same branch, so this current is I3, and here same branch, therefore this is I2, and I2 and I3 combines to form I1. Okay, so that is the direction of current. So how will you apply loop rule? Now if you consider the loop, what is the loop under consideration? P, Q, T, U. This one, P, Q, T, U, U, P. Okay, so first loop under consideration is P, Q, T, U, P, the closed loop. So since the cell is here, we can consider any assumed direction of current. So here the direction of current is from positive to negative. So any direction can be taken, clockwise or anti-clockwise can be considered as the direction of traversal. That means assumed direction can be taken as clockwise or anti-clockwise. So here, since cell is here, we can take cell positive to negative is considered as the assumed direction. So this arrow represents the assumed direction of current. So from positive to negative. So first, in order to apply loop rule, first we have to identify a assumed direction of current. If cell is here, is in the circuit or cell is in the loop, directly we can take from positive to negative can be considered as the assumed direction. Okay, so here cell is here, this positive to negative is the assumed direction. So this arrow represents the assumed direction. Now, according to loop rule, the total current is equal to 0. What is the total potential difference is equal to 0. So what is the potential difference across this resistance R1, I1 into R1? Here the assumed direction is like this, from positive to negative. So assumed direction and original direction are same, and hence its potential difference is taken as positive. So that is the first sign convention. So first sign convention is, if a resistance is here, this is a resistance, let this is the original direction of current. Through the resistance, this represents the original direction. And let this is the assumed direction. This is the assumed direction. If original direction of current and assumed direction of current. If original direction of current and assumed direction of current are same, then its potential difference is taken as positive. That is the first sign convention. Otherwise, if it is like this, a resistance is here, let this is the original direction of current, and assumed direction if it taken in the opposite direction. This is the assumed direction. Then its potential difference is taken as negative. Okay, so this is the first sign convention. If assumed direction and the original direction are same, then its potential difference is taken as positive, and if assumed direction and original direction are opposite, then its potential difference is taken as negative, like this. We can start from here, positive to negative. What is the potential difference across R1, I1 into R1? Original direction is same as the assumed direction. Assumed direction means like this. So both are same, therefore potential difference across R1 is positive. So what is that? I1 R1. Right. Now comes this resistance R2. What is the potential difference across R2? Current into resistance, I2 into R2. Assumed direction and original direction are same. This is I2, same is the direction of assumed current, and hence its potential difference is also taken as positive, I2 R2. Now comes which one? The cell. In cell, if you consider the cell, there is again another sign convention. The sign convention is, if cell is here, this is a cell. Let E represents the EMF of the cell. If a cell is considered, let this is the assumed direction of current. Okay, so assumed direction of current is here, the cell is taken under consideration. If assumed direction and an original direction from positive to negative, so assumed direction is this one, and the original direction, here it is potential difference is V1, here the potential is V2. So what is the potential difference? V1 minus V2. V1 is greater than V2, therefore its potential difference is taken as positive. So assumed direction is from positive to negative of the cell, EMF is taken as positive. Then if you consider a cell, its EMF is negative. Let opposite is the assumed direction. This is the assumed direction of current. Okay, assumed direction of current is in this direction. That means current flows from negative to positive, isn't it? Therefore, its EMF, in this case, EMF is taken as negative. So assumed direction is in the direction of negative to positive, then EMF is taken as negative. Assumed direction is in the direction from positive to negative, its EMF is taken as positive, like this. The sign conventions for applying loop rule are, we can take any direction either clockwise or anti-clockwise as the direction of assumed current. Number 2, the voltage across the resistor is positive if the direction of assumed current and actual current are same. The voltage across the resistor is negative if the direction of assumed current is opposite to the direction of actual current. The EMF of a cell is positive if the direction of assumed current is from positive to negative of the cell. Also, the EMF of the cell is negative if the direction of assumed current is from negative to positive of the given cell. So we have written the potential difference across R1 and R2. Then the next term, like this, it comes like this. Through the cell, here it is from negative to positive. Assumed direction is from negative to positive, isn't it? Assumed direction is from negative to positive. So since assumed direction is from negative to positive, what is its EMF? EMF is taken as negative. Therefore, here it is minus E equal to 0. That is the application of the loop rule. Right. Again, we can apply loop rule in this loop also. This loop. How will you apply loop rule in the loop? We can consider, see here there is no cell, therefore clockwise or anti-clockwise can be considered as the loop direction. Here again I am taken clockwise direction, same clockwise direction. Like this. What is the name of the loop? We can write Q R S T Q, isn't it? Q R S T Q. Now take the potential difference here, QR. What is the potential difference across resistance R3? What is the current flowing through it? I3. So its potential difference is I3 R3. Positive or negative? Same, no? Same direction. Original direction and assumed direction are same, therefore its potential difference is positive. Next comes this one, R2. What is the assumed direction? This is the assumed direction. But what is the original direction? Opposite, isn't it? So assumed direction is towards left, but original current is towards right. Both are in the opposite direction. If original direction of current and assumed direction are opposite, then potential difference is taken as negative. What is the potential difference across R2? It is I2 R2. Since both are opposite, we can put negative sign. No other elements are here. Only R2 and R3 are there. Therefore, equal to 0. Right. Now, here the main importance of a loop rule is we can find out the current through each branch. Here, how many unknowns are here? I1, I2 and I3 are the three unknowns. So if there are three unknowns, we have to consider three equations. Okay, so this is the first equation, this is the second equation, and third equation we can consider another loop like this, the bigger one. This loop we can consider, or otherwise we can consider the junction rule also. Here we can apply junction rule, isn't it? Here at the junction Q, I1 splits to form I2 and I3. Okay, so I1 splits to form I2 and I3. So using junction rule, we can write, from the junction rule we can write I1 is equal to I2 plus I3. So three equations are here, and using the three equations, we can solve the three equations and we can find out the value of I1, I2 and I3. Or otherwise the third equation can be considered as a bigger loop. This bigger loop can also be considered. Again, three equations will be there. Again, by solving the three equations, we can find out the values of I1, I2 and I3. So this is the sign convention used for finding the current. Once more, if the assumed direction and the original direction of current are same, potential difference across the resistance is positive. If they are opposite, potential difference is taken as negative. And here through the cell, current flows from positive to negative, its EMF is taken as positive. Through the cell, if current flows from negative to positive, then the potential difference is taken as negative, or EMF is taken as negative. Now, in the given circuit, we can apply Kirchhoff's loop rule and junction rule. So, circuit is given. This is considered as a complicated circuit because it consists of two cells and three resistors. Now, first we can mark the direction of current. Here, this is cell E1. What is the current? We know that the current flows from positive to negative. So, let this current is marked as I1. The current from the cell E1 is marked as I1. And let this current is I2. Okay. So, here I1, here I2. And this I1 at the point A and I2 at the point A, they combines to form, we can write I1 plus I2. Okay, so I1 plus I2 is the current flowing through the resistance R, and again here the current flowing through the circuit, this branch is I2, means the current flow this branch is also I2. Okay, and here the current flowing through this branch is I1, means this current is also I1. Okay, so here I1 plus I2 at this point, again here it is I1 plus I2. And again we can say that at the junction B it splits to form I1 and I2. So this is the correct circuit, direction of current. Now we can see how junction rule can be applied. So at the junction A, how will you apply junction rule? I1 and I2. I1 and I2 combines to form I1 plus I2. Okay. Now consider the loop. We can consider loop rule. How will you apply the loop rule for the loop? We can consider loop A, B, E1, A. A, B, E1, A. We can consider any loop. We can consider loop in clockwise direction or anti-clockwise direction, no problem. But here the since cell is there, we can consider the direction from its positive to negative. So this is the assumed direction of current I have taken. Because cell is here, the direction of current is from positive to negative. Assumed direction is from positive to negative. Now, we know that from point rule or from loop rule, we know that total voltage is equal to 0. Algebraic sum of voltage in a closed loop is equal to 0. Sum of voltage is equal to 0 means what does it mean? That is, the potential can be positive or negative. Then only its sum is equal to 0. So some potentials are taken as positive and some others are taken as negative. Then only its sum becomes 0. So how will you apply loop rule? For example, here the total voltage in a closed loop is equal to 0. That is called a loop rule. Here, how many voltages are here? Here, this is the voltage across the cell. That is the EMF E1. Next, voltage across the resistance. Next, voltage across this R1. So, 3 voltages are here and the total voltage or algebraic sum of the voltage is equal to 0 according to loop rule. Now, we can apply loop rule in the loop. We can write A, B, E1, A. That is the loop. A, B, E1, A. Applying loop rule. Now, total voltage. So, here it starts from the positive. So, what is the voltage across R resistance R? Because I1 and I2, I1 plus I2 is the current flowing through the resistance. So, what is its voltage? According to Ohm's law, voltage is current into resistance. So, it is I1 plus I2 into R. Okay, because assumed direction and the original direction are same. Therefore, its potential difference is taken as positive. That is the rule. So, here the voltage across the resistance R is I1 plus I2 into R. Next, here there is no resistance, so no need to find out the voltage. Here I1 is the current flowing through the resistance R1. So, what is the potential difference across R1? We can write plus I1 R1. So, potential difference across R1 is I1 R1. Okay. Now, the potential difference across the cell. Here, the potential difference across the cell is EMF E1. Now, here in this case, what is the sign conversion here? Through the cell current flows from negative to positive, isn't it? So, here the potential is greater and here current according to the original direction of current, this is the direction of current from positive to negative. But if current flows through the cell like this, if you consider this is assumed direction, if this is considered current flows from higher potential to lower potential. But in this case, current flows from low potential to high potential. Therefore, here the EMF is taken as negative E1. That is a sign convention. Okay, is equal to 0. So, total voltage is equal to 0. Algebraic sum of voltage in a closed loop is equal to 0. So, once more. Here this is the loop. Here this can be considered as assumed direction. Why I have taken this is the assumed direction? Because it's positive to negative. Clockwise or anti-clockwise can be considered as the assumed direction. Here total voltage. Here the voltage comes resistance. This is an element. So its voltage is I1 plus I2 into R. It is positive because assumed direction and original direction are same. Then potential difference is taken as positive. Then comes this resistance. Here also assumed direction and original direction. This is the assumed direction of current, isn't it? And original direction are same. Therefore, its potential difference is also taken as positive. And through the cell, current flows from negative to positive. Actually, current flows from positive to negative. Therefore, if current is flowing from negative to positive, its EMF is taken as negative. So, minus E1 equal to 0. Now, how will you apply loop rule in the second loop? What is the second loop we can consider? This is the second loop. Okay, here also we can consider clockwise or anti-clockwise. Here, since there is cell is here, the direction can be considered as from its positive to negative. From its positive to negative direction. Okay. So, we can write here it starts from positive. What is the potential difference across this current element? Current is I1 plus I2 into resistance R. Original direction is this one. Assumed direction is this one. Both are same. Therefore, its potential difference can be taken as positive. So, for the loop, what is the loop we can consider? A, B, E2, A. A, B, E to A. This is the loop, clockwise direction. Here we can write I1 plus I2 into R. Now, here there is no element. Next element is R2. What is the potential difference across this R2? I2 into R2. Because original direction and assumed direction are same. Therefore, its potential difference is taken as positive. So, plus I2 R2. Now, again here, the direction of current is from negative to positive. Negative to positive means its potential difference is taken as negative. Right. Minus E2 equal to 0. Now we can solve the two equations and we can find out the value of current or potential difference across the resistance. Okay, so this is an application of Kirchhoff's loop rule. So this is the method by which we can write the equation, and solving the equation we can find out current. Now in numerical, using Kirchhoff's rules, calculate the values of I1, I2 and I3. Here the circuit is given. In the circuit, here from the cell 12 volt, a current is coming I1, and here at the point junction, at the junction B, current I3 is going, and here from the cell 6 volt I2 is coming. At the junction B, I2 and I1 combines to form I3. So this is the circuit given in the question. So using Kirchhoff's rule, we have to find out I1, I2 and I3. For that, in order to apply Kirchhoff's rule, we have to assume a direction, assume the direction of current. It can be clockwise or anti-clockwise. Here I have taken clockwise direction because here cell is there, no? So the direction of current is from positive to negative. So here the assumed direction, let it be from positive to negative, that means clockwise, through the loop A, B, E, F, A. So for the loop A, B, E, F, A, for the loop A, B, E, F, A, how will you apply Kirchhoff's rule? Kirchhoff's loop rule is total potential difference, algebraic sum of potential difference in a closed loop equal to 0. Here there are three elements. 5 ohm is a resistance in the loop, 2 ohm is another element, and the cell is there in the loop. So potential difference is equal to 0. So what is the potential difference across 5 ohm? I1 into 5. The original current is in the upward direction, assumed direction also in the same direction. Therefore, its potential difference is positive, 5I1. Now, what is the potential difference across 2 ohm? That is again plus 2I3, same direction. Now, here it is from negative to positive. That means lower potential to higher potential. Therefore, it is minus 12 equal to 0. Or we can write 5I1 plus 2I3 is equal to 12. Let that is the first equation. Again, we can apply loop rule in the second loop. Here in the loop, this one C, B, E, D, because here also a cell is there, we can assume this is the direction, anti-clockwise, because it's from positive to negative. Right. So either we can use clockwise direction or anti-clockwise direction. If a cell is there, it is easy to take from its positive to negative as the assumed direction. So for the loop, what is the second loop under consideration is C, B, E, D, C. Okay, C, B, E, D, C. Applying loop rule, how will you apply loop rule? That is 3I2, positive, no, same direction, therefore 3I2 is positive. 3I2, then it is 2I3 plus 2I3. 3I2 plus 2I3, here it is from negative to positive, same from negative potential to positive potential, therefore minus 6 is equal to 0. Or rearranging 3I2 plus 2I3 is equal to 6, that is the second equation. Right. Here how many unknowns are here? I1, I2 and I3 are the three unknown current. So in order to solve I1, I2 and I3, we have to find out, we have to consider three equations. So two equations already we have considered from the loop rule. Third one, whether we can apply junction rule here. Yes, we can apply, no? I1 and I2 combines to form I3. So that is a third equation. So here from the junction rule we can write I1 plus I2 is equal to I3. That is the third equation. So three equations we have considered. Now we can solve the three equations and find out I1, I2 and I3. Here I1 and I3, here I2 and I3. We can substitute I3 as I1 and I2, I1 plus I2. Okay, so from the first equation we can write 5I1 plus 2 into I3. What is I3? I1 plus I2 is equal to 12. So we can write 5I1 plus 2I1, that is 7I1 plus 2I2 is equal to 12. Similarly, second equation can be written as 3I2 plus 2I3. What is I3? I1 plus I2 is equal to 6. Simplifying, we can write 2I1 plus here 2I2 and 3I2, therefore 5I2 is equal to 6. Now we can solve the two equations by neutralization method. Here we can multiply this equation by 5 and we can multiply these equations by 2. Okay. So here this is multiplied by 5, this equation is multiplied by 5 and this equation is multiplied by 2. Right. So 7 into 5, therefore it can be written as 35I1 plus 10I2 is equal to 12 into 5, 60. This equation is multiplied by 2, therefore it is 4I1 plus 10I2 is equal to 6 into 2, 12. Okay, then we can subtract 35 minus 4, that is 31I1 plus 0 is equal to 60 minus 12, that is 48. Therefore, I1 can be written as 48 divided by 31 ampere. So, we got the current I1 as the 48 divided by 31 ampere. Now, substitute the value of I1 in any one equation. Here we can substitute in this equation 2I1 plus 5I2 is equal to 6. So, 2 into what is I1? 48 divided by 31 plus 5I2 is equal to 6. On simplification, you will get I2 is equal to 18 divided by 31 ampere. So, we got the values of I2. Now, how will you find out I3 in this third equation? I1 plus I2 equal to I3, isn't it? So, I1 plus I2 equal to I3. So, I3 is equal to, add the two terms, 48 divided by 31 plus 18 divided by 31. So, you will get the answer as 66 divided by 31 ampere. Okay, so using Kirchhoff's rule, in this method we can find out the values of current. Okay children, thank you.